So guys, today we're learning about percent error, and this can be a bit tricky, so stick with me. Percent error basically means that we're comparing an approximate to an exact value. Since we're human, we often deal in approximate. We're not perfect. Basically, this is the imperfect measurement. So let's look at this example. A science experiment calls for 150 milliliters of water, but despite believing he's perfect, Mr. Wolfenden isn't as perfect as he thinks, because when he measured out the water for his experiment, he measured 147 milliliters instead of 150. So I want you to find the percent error. To do that, we have to subtract the approximate from the actual, or let's call this the exact. We're looking, this is going to be the exact amount for the experiment, but this is what he did, the approximate. So we'll just go ahead and subtract those. 147 minus 150. And guys, I want this to be an absolute value. So when we take the absolute value, 147 minus 150, it would give me a negative 3, but the absolute value of that would just be 3. So the error, and I'll write this off to the side, my error is 3, and my exact amount that I wanted was 150. So now let's move on to step 2. I'm going to erase these really quickly. Okay. So I want to set this up as a ratio, and we're going to have the amount error over the actual amount, and we'll set this equal to our percent. So make sure you write this down in your notes. We'll come back to this over and over. So our amount error we already figured out was 3 over the actual amount, or the exact amount, which is 150. Set it equal to the percent. Cross multiply, so I have 300 equals 150x. Go ahead and divide by 150. X equals 2% error. Okay, let's keep going. I have another example to try. So this one's a bit different. So here we're filling treat bags with 10 ounces of goodies. So that is the exact amount that I would like to have in each bag. The acceptable percent error when filling the bags is 6%. Which treat bag has the right amount? So remember that we were going to go ahead and take our actual and subtract my exact, or vice versa. It doesn't really matter when I'm doing my when I'm taking an absolute value. I'm sorry. So I'm going to find my amount of error, and I'm going to say 10 minus 9.5, and that will give me 0.5. So I found my amount of error. Pen's not writing very well. There we go. Equals error. So we have the error on the top, which is 0.5, the exact on the bottom, which is 9.5, and then we will set it equal to that ratio so we can find the percent. Cross multiply. 100 times 0.5 would give me 50 equals 9.5x. Oh, I just made a mistake, didn't I? Hold on, I caught my mistake, and strangely, I'm human too. So I don't know if you guys caught my mistake, but as I was doing this is my error on the top, and this is my exact amount on the bottom. The exact amount that I wanted, which was 10 ounces. So now, let's go ahead and do that. 100 times 0.5 is 50, and then 10 times x is 10x. Go ahead and divide by the odd guy out. 5% is our error. So it looks like, since 5% is my error, this bag is good. It works. Let's try for the next bag. See how we did. Or how we did with filling it if we made a mistake here. So bag B, I need to find what the error is, so I'll go 11.5 and I'll subtract 10, which gives me 1.5 for my error. This time I'll remember that my exact amount was 10 ounces, so I wanted exactly 10. And we'll go ahead and set it up as a ratio. Cross multiply. So I have 150 equals 10x. Divide by the odd guy. So 15% is our percent error, which is way too big. We gave this kid way too much candy. So this bag, no good. Percent error is too large. I have one more example for you. In a crowded arena, I'm trying to find my highlighter here. I know it's in front of me. There are 250 seats, or 250 seats are counted. If there's a 20% error on the count, what is the range of acceptable number of seats? This one's a bit different and a little bit trickier. So this time it gave me some different information. It told me my percent error is 20%, and I always set that out of 100. And the amount that I counted is 250. So we'll just go ahead and cross multiply. So I have 250 times 20, which is 5,000. I should have an x right here. Equals 100. X. We'll divide by 100. Divide by 100. I like just crossing out those zeros. That kind of helps me. So my x equals 50. So my error is 50. That's not the whole answer though, because it says the range of acceptable number of seats. What is the range of acceptable number of seats? Well, we counted 250, so it's going to be plus or minus 50 seats either way. So the range, if I add 50, would be 300 seats. 2, if I subtract 50, 200 seats. So we have a range, an acceptable range with a 20% error of 2 to 300 seats.